So, all week we've been working on problems where we found out that the mechanical energy actually was the sum of the kinetic energy added to the potential energy. So, we also noted that no matter at what point in time, at what instant through the movement, the mechanical energy was going to be constant. So even we could break it down into saying that initial value of kinetic energy added to the initial value of the potential energy was also constant. And for talking sake, we said too that the final was equal to the final potential position. So, even if they vary in time, their sum will always be constant. So, we're going to start with this basic knowledge here, okay, which stems from the constant mechanical energy in a system. And we're going to try to solve this problem, which involves an initial velocity that is different from zero. Because so far, we've had problems where the velocity was at zero at the beginning most often, and the height was zero at the ending. So we were able to cancel the potential energy at the final position and cancel the kinetic energy at the initial position. But this problem is going to show us that we can solve it even if we have different values for velocity, initial velocity, or final position. So let's start. Two balls of the same mass arrive at the bottom of a ramp with different velocity. The first one reaches the bottom of the ramp with a velocity of 2.5 meters per second, while the second one has a velocity of 3 meters per second. If after reaching the bottom of the ramp, the balls are to go up an opposite ramp, find in A the difference of height they will reach once stopped. That's our first question. The second question is the velocity of the ball that ends up at the highest point on the opposite ramp. I guess something's missing here. So it's the velocity of the ball that ends up at the highest point once the first ball has stopped. Sorry about this. Once the first ball has stopped. Okay, I will sketch it out for you, and you will understand what this means. Okay, so we have a ramp. I'm going to draw the sketch the ramp. Okay, and opposite, once the balls reach the bottom, they are going back up another ramp. Okay, we don't know the height of this ramp, so we don't have this height here. We don't know it. What we have though is that both balls, okay, they don't have to go down at the same time, but we can measure some things. Once they reach this point, okay, that is, we're going to consider this to be the initial velocity because we don't have other velocity, and we want to find the height once they stop. So once they've gone up this ramp, at one point they will have stopped. So we're going to consider this bottom part here to be the initial motion or moment, and the stopping point to be the final moment. Okay, and we have two different velocities. Okay, v initial for the first ball, as we said, is 2.5 meters per second. For the second ball, the initial value of the velocity will be 3 meters per second. Now, we can instinctively say that because they have different velocity at the bottom of the ramp, going up the ramp, they will actually go up different heights, right? So one's going to go to this level, the other one's going to go to that level. But at both of these levels, their velocity, so their final velocity, will actually be 0 meters per second. Okay? What else can we find out? Well, we know that initially, in the initial position, the height of the balls for 1 and 2, okay, so it's going to be the same, and we're going to consider this to be a reference position, so it's going to be 0. So height 1 and height 2 are both 0 meters. And we're looking, initially I should add a little I here, and we're looking for the final height of the first ball and the final height of the second ball as well. So, so how can we do this? Well, like I said, we're going to be starting with this equality here. Okay, so I'm going to calculate for the first ball here. So here's my number one ball. I've got an EKI plus an EPI equal to an EKF plus an EPF. Okay, one thing that I don't seem to have is the mass of these balls. Now I've got two options. Because mass is in all of these, okay, it is the equation for finding kinetic energy is 0.5 times mass times velocity squared, initial velocity, plus mass times gravity times the initial height. So mass being everywhere, it really doesn't matter what is the mass, because I'll show you something here that you may or may not foresee. But if it's too complex, give it a number, because the two balls have the same mass. It does say that. So give it the number 1 if you want to, and that will help you figure what it is. But if I just consider the two equations, okay, 0.5 times m times vi squared plus m times g times hi, there is a common factor here, and it is the value of m. Same thing on the other side. So I can actually put it in evidence in front of my bracket of the two terms that are left. Okay, so I'll have GHI here left. I can do the same on the other side, and you'll see where I'm heading with this. 0.5 V final squared plus GH final. Okay, so if I want to, I can isolate, I can actually remove by dividing by m, and if to remove it from my right hand side of my equal sign, let's say, so I would divide it by m on the other side, and look at this, m divided by m is 1 anyways, so they cancel out naturally without hurting anything, and we end up with this here. GHI is equal to 0.5 times VF squared plus GH final. Okay, so I got rid of the mass. Lucky, how lucky is that? So now I can start putting in some numbers, because I'm really looking for the final height here. Okay, this is still for my first ball. But really, this is what I'm going to be looking at. I could go to the point of isolating my h, so I would then move my 0.5 VF squared to the other side. I could put in evidence my 0.5 in my g, and then, but anyways, I can do it from here, and if it's too complex to do it any further, then I suggest you start putting some numbers in. So 0.5 times my initial velocity, which is in the first case of VI1 of 2.5 meters per second that I need to square, plus 9.8 times my initial height, which I know to be 0, because I decided that the bottom of the hill would be, or the bottom of the ramp would be my initial position and my reference point. That should be equal to 0.5. Well, now my V final, when my ball is reached, the maximum height on the opposite ramp is going to be 0. Okay, so I'm going to pretend that the ball is stopped at its maximum height, and I will be left with 9.8 times the h final. So I can eliminate these two values, and I will have 0.5 times 2.5 squared, which gives me, for an answer, 3.125, and all of that will be equal to 9.8 times HF. So of course I need to isolate my HF, so I divide both sides by 9.8, and my final height in the case of my first ball will actually be 0.318 meters. if I continue trying to answer this problem, okay, I'm going to find, I'm just gonna sort of square it up so I don't lose it. I'm gonna find for my second ball, what is the maximum height? Because remember the question says find a difference of height. So I need to find the two height and subtract them from one another. So since I know that I'm eliminating the mass, and I can start from here because really that's where I started to put some numbers in. So I'm going to recopy this equation because it's still very important that you show me where you're starting from or which equation you are using. Okay, so GHI 0.5. I don't need, if you've done the proof once, I don't need to see it all the time, but I don't want you to learn proofs by heart. I want you to demonstrate them. So that means show me each step. Okay, so, but we know that there's no mass like that. The rest of the situation doesn't change, so we're going to leave it like this. But I'm going to use the V initial 2 and HI 2 and V final 2 and HF 2. Okay, I'm not with ones anymore because I'm working with the second ball. So I know that the 0.5 times the velocity this time is 3 meters per second squared, that is squared, plus 9.8 times 0, because the height at initial moment is still 0. We're basing it on the bottom of the ramp. And the velocity at once the ball is stopped and reaches its maximum height will be 0. So, and I have 9.8 times the H final of the second ball. So this is 0, this is 0, so I'm left with 0.5 times 3 squared, which is 4.5, is equal to 9.8 HF squared. So if, not squared, sorry, second. So if I divide by 9.8 on both sides, I end up with a final height of the second ball at 0.459 meters. 0.459 meters. Okay. So I figured that max height of the second ball. Now I only need to find the difference of height, right? Okay, so the difference of height at the final moment. So I'm going to take the final height of the highest one, right? So 2, because 0.459 is greater than 0.318, and I'm going to subtract the final height of my first ball. So I've got 0.459 minus 0.318, and that gives me for answer 0.141 meters, which is the same as 14.1 centimeters. So as a summary, the difference of height, okay, between the ball that was at 3 meters per second at the base of the ramp versus the one that was at had a velocity of 2.5 is actually 14 centimeters. Okay, so one goes up higher than the other of 14 centimeters. Now if I tried to answer B, because all of this was for A, right? Well, I try to answer B. I'm looking for the velocity of the ball that ends up at the highest point. So which is the ball that ends up at the highest point? It is ball 2, and we could instinctively figure that out. On the opposite side, once the first ball has stopped, so at the level, if they were to be thrown at identical times, or reach the bottom at identical times, okay, so they're going up the ramp, right? Ball number 1 is going to stop here, let's say, while ball number 2 is going to stop here. But at this height, where ball number 1 stopped, what is the velocity? Okay, we're going to look for the final velocity of ball 2. That's the question. Okay, that's the question they're asking us. Is like, at that height, it's what is the speed? What is the velocity of that second ball that's going to go above the initial one? So I'm going to start by just rewriting what I have to work with. Okay, and and then I'm going to use my qualities. So the mass, I don't have the mass, but I don't need the mass. The initial height hasn't changed. It's still 0 meters. Okay. The final height though is the height of my lowest ball, this one here. Okay, and we're gonna stick to meters because my velocity is in meters per second, so kind of important to keep it in meters. Okay, so what I'm looking for is the velocity of my second ball at this height, while knowing that the initial velocity at the base, right, is 3 meters per second. Okay, so I'm looking for final velocity. So V final. So I can start because I'm still in the same problem, because I've done my proof once. I can start with this relationship again because it's the same problem. I don't have the mass. I don't really need the mass. Okay, so 0.5 Vi squared plus GHI is equal to 0.5 V final squared plus GH final. So I've got 0.5 times 3 that needs to be squared plus 9.8 times 0 is equal to 0.5 times the final velocity squared, which is what I'm looking for. So I obviously don't have it, but I have a final height, which is going to be the height of the first ball. Okay, that's max height, 0.318. So when I do these calculations, this is 0, so I'm left with 4.5 here is equal to 0.5 V final squared plus 3.1164. Okay, and do keep as many decimals as you can until the very end. So if I minus from 4.5 3.1164, 4.5 minus 3.1164, that gives me, and I'm gonna put it in one line because I think you know how it works. So 1.3836 is the result of that, and that is still equal to 0.5 times V final squared. So now I need to divide by 0.5 on both sides to isolate my V final squared. And my V final squared is equal to 2.7672. So to have my final velocity, I need to square root, right? And I'm gonna write my final velocity right here just because I have more room. And my final velocity, and I'll explain to you where that is 1.66 meters per second, but that is at an h of 0.318 meters. So at 31.8 centimeters, my fastest ball will be going at a velocity of 1.6 meters per second. So this is how you can solve a problem for which you don't have mass and that the initial velocity or the height is not necessarily 0. Hope this has helped.